Alan Stoddard, and I'm going to be your instructor today. As everyone's aware, things are done slightly different with these courses. With everything that's going on in the world today, these courses are all going to be remote, which is okay, but it does give us a few little problems. Basically, with me not being in the classroom with you, I can't see everybody, so I don't get that interaction with the class. But there's a couple of things I want to go through with you before we look at the material. Just because we are on WebEx, and although the course that we covered yesterday went without any hitches, we are reliant upon a lot of technology. One of the things we have to do once we start to present the material is that we have to lock the lesson out, so nobody else can join the WebEx meeting unless they're given permission to. So at the moment, everybody, about 65 people at the moment online. Hopefully nobody will drop out of the session once we start it and once it's locked out. However, if you do drop out of the session, and it does happen, if you do drop out of the WebEx, then when you try to join again, you'll be put into like a virtual waiting room, so to speak, like a foyer where I can see people waiting to come back in, and I have to allow you back in. So if you do get dropped out, don't panic. We can get you back in. I try to monitor it as much as I can whilst I'm teaching. But if you are waiting to get in for 10 minutes or something like that, then ping me an email, or feel free to if you have link and you've got a BEMS ID and you have a link account, then feel free to ping me on link. But I'm more often than not catch people trying to get back into the lesson. So please feel free to just ping me an email or something if you want to get back in. I'm just going to show you my email address. I'm hoping everyone can see this. If you can't, let me know. So this is my email address, and as I say, I'm going to be covering the first day today. I'm going to put my email address up when we take breaks and such like, so you've got it in front of you. With WebEx and not being in the classroom, it's quite difficult to manage questions at time. So what I try to do is everyone has the ability to unmute themselves. What I normally do is before I start to present, I'll mute everybody, and I will ask people, if you do want to ask a question, that's perfectly fine. Unmute yourself, ask your question, and then I would ask that you would mute your microphones again. We've had all kinds of background noises in the past where people have forgotten to remute themselves. Arguments with the spouses, kids fighting, dogs fighting, all kinds of stuff. So no problem with asking questions, but I would ask that you would mute yourselves once you've asked that question. Depending on how many questions we get, I don't want to be batting questions all day, because I say there's quite a lot of people on the course. There's some questions obviously I'll be able to answer straight away. Other questions I may have to go and get an answer to. And because the course is such a short period of time, it's only 2 days, I may not be able to get the answer to you before the course is finished. So if you do have a question that I'm unable to answer, or we get inundated with questions, then what I would ask you to do is to send me that question via an email to this email address, and I will reply to it. I will do my best to reply to it as soon as possible, but again, depending on how busy I am, will determine how long that reply takes. But I will answer the email, okay? It's also good for my grey matter that's getting older and older every day, is that if I'm unable to answer a question, it does remind me that somebody asked that question, so I don't forget about it. I don't like to leave doors open when I've done training. I like to make sure all the doors that have been opened have been closed. So I would ask that you would ping me an email if you have questions that I'm unable to answer, just so I don't forget you, that's all. So that's my email address. The other thing I'm going to mention to you is you do have the chat. We do have chat. I know people have used it already on the WebEx. So you can send me a question via chat if you don't want to ask it in public. That's perfectly fine too. But again, I may miss it. I do try to monitor these things, but it's quite a lot to monitor on these WebEx, especially with so many participants. So yeah, if you want to send me a ping via the chat, then that's fine too. I will do my best to reply to that. I've just put on the screens at the moment the normal hours that we normally do. I appreciate that people are spread out all away, all across the world, I guess, different time zones. Here in the UK, where I'm based, my local office is Gatwick, near London, but I'm actually based just south of Manchester in Cheshire. For anybody who knows the area, pretty much next to Manchester Airport, to be honest. So in the UK at the moment, this is a very horrible, dull, miserable day in Manchester. Most days are. We get about 2 days of sunshine, hence why I'm so pale. And that is, it's now about 12 in the afternoon, just after midday. So I do appreciate that people are on different time zones, and obviously some people are going to be just about waking up, some people are going to be halfway through the day, and for some I do appreciate it's evening time and you may be going into the early hours. So we look at doing about 6 hours of training in total. The 6 hours of training, we will take breaks, obviously. I like to go for maybe an hour or so. An hour and a half, and then we'll take a 10-minute break or something, just to get people moving, get the heart beating again, and get yourselves a coffee or cigarette break or something of that nature. But I will be taking about an hour break at some point, probably in about 4.5 hours time, just so I can get some dinner and others can get a brunch or lunch or even breakfast maybe. But we will be doing about 6 hours teaching. Okay. Depending on how we go with questions, that might take a little bit longer. Shouldn't take much longer, but it may finish a little bit earlier even. Depends on how many questions we get. Okay, so that's the basic layout. I do appreciate that you probably don't have class notes, student notes, whether it's a manual or a PDF. I know some people do have them. Everything that you're going to see today with myself, you've already seen. I'm assuming that most of you, if not all of you, have sat on the differences class, the NG to Max differences classes, or you've done the full up line and base course. The presentation that I'm going to go through today consists primarily of slides from those courses, because it is just a refresher. You know, you're going to see probably not much things that are going to be new than what you covered when you covered your line and base or differences class. There may be the odd slide change where a slide's been updated, we've got some better information or something's changed on the aircraft, and I'll go through some of those changes that you'll possibly be coming across in the near future with the Max. Okay, even though it is quite a new aircraft, the Max itself, there are some changes coming already to the aircraft, and I'll mention those as we go through it. But as I say, most of the material you're going to see is what you would have already covered at some point. So, as I say, you probably don't have a separate note file for this. Okay. Just like I say, a polite reminder, really, that I do try to make sure everyone's muted as they enter the meeting, so we're not disturbed. If you do have questions, feel free to either send a chat message or you can ask me over WebEx. That's fine, but just as long as you remember to mute your microphones again once you've asked that question. Okay. So I think we've got 72 people now, so a few more people have joined us. That's good. I'll just bring up the presentation that we're going to look at. And again, I'll just leave the presentation open for another 5 minutes, the WebEx open for another 5 minutes, just to make sure we've got everyone we want. And then I will lock the lesson out. And then, as I say, if you do drop out the lesson, when you try to get back in, it won't allow you in straight away. I have to then admit you, basically. So I'll keep an eye on that as people drop in and drop out, depending on your connectivity. Okay, so as I said to you a moment ago, the course I'm going to be covering today is just an overview, really, a refresher of material that you've probably seen before. Okay, obviously, when we're talking about the Max itself, this picture, the first picture, funny enough, is of the NG. But I like to show this picture. One of the things I talk about when I cover a line and base or Max differences course is the difference in how the aircraft sits when it's on the ground. For those of you with bags of NG experience or worked on NGs in the past, you'll know that the NG, when it's on the ground, it sits nose down. It tilts forward. Okay. This is quite a good picture because the next picture I'll show, it shows you that we've actually lifted the nose of the MAX aircraft. We've extended the nose gear. Okay. We've extended the nose gear because of the bigger engine. Okay, we've got a much bigger engine on the MAX aircraft. This is a 61-inch fan on the CFM, and on the MAX it's a 69-inch LP fan on the front. So you can see, if I flick between the two pages, you can see how that aircraft, the nose of that aircraft, pitches up on the MAX, and that is because of the larger nose gear. Okay, to give us that ground clearance for our engine. So when it comes to the dimensions of the aircraft, the vertical stabilizer, the rudder, is lower on the MAX than it is on the NG. So if you can get an NG inside your hangar, the MAX will certainly fit in when it comes to the rudder, okay, the vertical stabilizer, because it is slightly lower. So that's one of my primary reasons why I show this picture, is just so you can see the difference between the pitch of that aircraft. Because we've increased that nose leg slightly, it has increased the external power panel, okay, where you plug your stinger in, your rig in, where you plug your headset in so you can talk to the ground crew. There's been a bit of feedback from the airlines already. I know the MAX hasn't been in service for some time now, but there has been some feedback from airlines regarding the height of the aircraft now, and that some people are struggling to hit that call button in there for the flight deck to plug their headsets in. So Boeing are actually fitting a new panel. It's in addition to this panel on the side, so it's an additional panel that's going in the nose gear bay. Okay, and on there you'll have your crew call button to call the flight deck, and you'll also have a position to plug your mic and headset in. Okay, so that's going in the nose gear bay on the right hand side. If you're looking forward in the nose gear bay, it's up on the right hand side there. So that's something else that's being put in at the moment because of that additional height. This is just showing you the three series of aircraft. I know we have a Dash 10 now. None of our line and base notes that you guys, I would imagine, have covered for the line and base or differences would have really covered anything to do with the Dash 10. None of our notes, none of these notes cover the Dash 10 really. Anything you see is primarily orientated around the Dash 8, and then I'll just mention the differences between the 7 and the 9. So this is showing you the dimensions really of the Dash 7, Dash 8 and Dash 9 aircraft, and you can see the height is all the same height. There's no real difference in the height. Fuselage length, obviously, different plugs depending on the size of the aircraft itself. The Dash 10, as I say, we're not showing it on this picture, but the Dash 10 is again longer than the Dash 9. The Dash 10 works out about 43.8 meters long, okay, and seats around about 230 passengers, range of about 3,300. But again, it depends on configuration and what the airlines are going to do with it. But it gives you an idea of the sizes of the aircraft, and then obviously the Dash 10 on top of that. The winglets. So there's quite a few NGs out there, later NGs, that have got these winglets on them as well. It was an option on the NG, it is an option on the NG. On the MAX, it's a standard fit. The winglet itself, obviously there to improve aerodynamics, to improve fuel efficiency. The actual winglet itself is made out of carbon fibre. The upper and lower blades are both made out of carbon fibre, as are the spars themselves within those upper and lower winglets. All the panels, you can just about make out some of the panels at the back, the trailing edges of these winglets. Again, they're made out of carbon fibre, but they have a honeycomb centre. So you've got the laminate and the honeycomb in between, giving it the additional strength, but also making sure that we keep it as light as possible. We don't show on here, but we do have static wicks that you can on the trailing edges of these winglets. They are obviously bonded to the structure itself of the winglet. The top winglet itself has a tip, a cover to it. That's alloy, aluminium or aluminum, depending on which part of the world you come from. But it is an alloy tip on that top wingtip, top winglet. The lower winglet, this is actually an LED. It's a pure white LED. It shines down and backwards. We want to try to keep that winglet as illuminated as possible, as visible as possible, especially in an evening time, night time when it's getting darker. The lower winglet, when you have a fully laden aircraft, so you know you've got fuel load, cargo, baggage, whatever on board, the winglet's only about 2.8 meters off the floor, that lower winglet. So it's quite easy to drive some kind of servicing vehicle into it. It's happened before on the NG. I'm sure it will happen again. But we do try to reduce that risk as much as we can. So we put that small little LED, bright single LED at the bottom there that shines down and more shines backwards more than forwards, because we do have the strobes obviously and the position lights. As you can see here, the position light is on the upper winglet. Again, it's a pure LED system. For those of you who've got 787 experience, and again now quite a few other aircraft have them, it's an LED array for the position light, and also the strobe. It's not a strobe in the true sense. It is again an LED array, okay, but pure white LED lights. That is the actual light itself is part of that leading edge of the lower winglet. Okay. So they're the winglets themselves. They are a standard fit on the MAX. They do improve the efficiency of the aircraft. Okay, so just be aware of those. The flight deck. So again, something that's changed quite significantly is the flight deck of the MAX aircraft. As we go through the lessons with myself and also with Brian, who's going to be covering the lessons tomorrow, we'll talk about the different locations of components that have moved within the flight deck. Just as an intro really to it, I'm sure you're all quite aware, we have made some significant changes to the flight deck. Obviously the biggest change that you can see are the displays. The displays themselves are a liquid crystal display. They are currently fitted to 787 and also the MAX. So they're the same panel, the same part number. These are going to be changed at some stage, okay? I believe it's sometime next year. Whether that's been extended now, been moved to the right with what's been going on with the aircraft, I'm not 100% sure. But these displays will be changed, being introduced on the -10 initially. They're going to be changed for touchscreen displays. The touchscreen displays currently being certified on the 777X. Once they're certified, they'll be then fitted to also going to be fitted to 787 and fitted to the MAX, starting with the -10. So the 4 screens in the flight deck on the MAX, the screens on the 787, the screens on the 777X will all be the same, and they will all be touchscreen. Okay, but at the moment on the MAX, there's no touchscreens unless you have the fixed electronic flight bag that Boeing provide. Okay. They will be the only touchscreens on the aircraft. When I say nothing's touchscreen, then that's true. Nothing is touchscreen, but you can touch every screen you want if you wanted to. It's just that nothing will happen. Obviously, just get a load of fingerprints on there and annoy somebody. Okay, we've got somebody there who's not muted. Okay, there we go. So as I say, that's some changes that are coming already to the aircraft. New displays, new screens. We've also moved the landing gear lever, as you can see here. The landing gear lever on the NG was more towards the first officer side, pretty much out of reach of the captain. He had to reach right across to get that landing gear lever. So we've centralised that now. The nose wheel steering switch for the alternate nose wheel steering, again, that was more towards the captain's side. It was actually on the captain's side. So again, wasn't in easy reach of the first officer. So again, we centralised that. We've moved the integrated standby flight display as well, made that more central. Apart from the 4 displays here, the outboard displays, which are primary flight displays, and the 2 inboard ones, which we class as MFDs or multifunction displays, the lower display that was on the NG has been removed. and we've got this multifunction panel in there now. Multifunction panel, as its name suggests, allows us to do different things with different systems on the aircraft, but we do use it to control our displays or certain aspects of our displays, okay? Primarily to do with the multifunction displays, the inboard displays. The glare shield with the mode control panel, again, no real differences to the mode control panel. The EFIS controls, one for the captain, one for first officer, they look like pretty much like a standard EFIS control panel. They look very similar to the ones that are fitted to the NG, but they're not the same. Okay, well, we've got a better picture of those coming up in a moment, and I'll just go over the differences really. Over the top of the glare shield, you can't see them at the moment, but we've also got the remote light sensors that are monitoring the ambient light in that flight deck, and automatically they will then change the brightness of those displays in the flight deck to keep them visible to the crew. The attention getters, the six packs, that type of thing, nothing's really changed there. We've got a couple of, maybe depending on what options you're taking on the NG, but we've got a couple of switches, microphone switches, clock switches on the glare shield there for the chronograph clock, the stopwatch on the display. So again, we'll look at those in more detail. The head-up display system, that is an option. Not everyone's taken it, but it is an option. If you do have it, it is pretty smart. It's not the one that's fitted to the 787. It's a completely different system, but it's there. It is an option if you want it. These fuel cutoff switches, I do still hear them being referred to as levers or levers, again, depending on which part of the world you come from. But they are an actual switch. Some of the later NGs were fitted with those fuel cutoff switches. Most of the NGs had the actual levers themselves, but all the MAX aircraft have those fuel cutoff switches. Okay. So again, just point out a few little things that we've got on the aircraft that might be slightly different, just to give you a little bit of a refresher. Again, something that's new to the MAX, or well, say new to the MAX. Some of the NGs do have an onboard network system, but it certainly isn't as complex and doesn't give you as much flexibility as the one that's currently fitted to the MAX. For any of you who've got the 787 experience, and I should have mentioned, and I do apologise, I've been with Boeing now for nearly 14 years. 10 of those years, just over 10 of those years, were on the 787 as an instructor. The last 3.5, 4 years have been on the MAX. Before that, I was with Airbus for 5 years, mainly single aisle, 320, 380 at the end. And before that, I did 18 years at BAE as a senior tech and night shift supervisor. So I've got quite a lot of 787 experience as well. And for those of you who do have that 87 experience, then the onboard network system and the interface that we use for the maintenance control function, or CMCF as it is on the 87, is very similar. And again, it's something that Boeing are trying to do with their aircraft. They're trying to make a lot of things as common as possible. So if you can operate the onboard maintenance function on the MAX, you should be able to operate it on the central maintenance computing function on the 87, and you should be able to operate it on the 777X, because the format's pretty much the same. Not as much functionality on the MAX, because the MAX isn't as complex as the 87 or 777, so not as many systems report to it. But the ones that do report to it, you do have, you do have the ability to get more information on those particular aircraft systems. So we've got the onboard network system, the network file server. That's down in the electrical equipment bay. It's like an electronic filing cabinet. Okay, and again, I'll go through that in more detail later on today, but think of it as a filing cabinet. It does a few other little bits as well, but it keeps all the files basically, okay, electronically. We've got the onboard maintenance function, which is like a central maintenance computing function. And again, we'll look at some of that information that's available to you. And then we've also got the wireless connectivity. So terminal wireless or crew wireless, optional on the aircraft. Okay. We also have terminal cellular, and to be honest, just as with most aircraft, certainly the 787, most of the airlines use terminal cellular above terminal wireless, because obviously if you're using Gatelink, then you're going to have to pay an airport authority for that, for the use of that, or you probably will. You do in the UK, most airports. Whereas your terminal cellular, you can pretty much pick up a cellular network, phone network, pretty much anywhere in most countries these days. Terminal wireless, well, obviously that's reliant upon the airfield itself. But either way, whichever connection you have, terminal cellular, terminal wireless, it allows you to connect this network file server to your airline's back offices, to the servers. So you can the aircraft can automatically update the latest software loads into this network file server, a filing cabinet. Okay. So again, we'll look at the ONS a little bit later on today and what that can provide us with. Spoilers. So I'm not really going to cover flight controls. That's going to be covered tomorrow, and I believe Brian's going to cover that for us. But I guess one of the biggest significant changes to the flight controls is the spoilers themselves. All the spoilers, flight and ground spoilers, are controlled electronically by a computer. Okay, the spoiler control electronics. You still have the ground spoiler control unit, but it's the spoiler control electronics that's actually signaling that ground spoiler control unit to deploy the spoilers for ground. The flight spoilers are controlled electronically via the spoiler control unit, but they are hydraulically powered. The hydraulics go directly to the actuators on those flight spoilers. They don't go to a control unit, a separate control unit, and it's the spoiler control electronics that controls those actuators for the flight spoilers. So it is a fly-by-wire system. I'm sure you're all aware, the primary flight controls, elevators, ailerons, rudder, again, they are still the old cable quadrant controls. There's no real fly-by-wire technology there. Okay. So again, some slight differences there. Obviously the engine, again, I won't be covering the engine. Brian will cover that tomorrow, but a completely different engine, as you're all well aware about that. So, the flight deck, and this is probably one of the biggest changes that we've seen inside the flight deck itself, are the displays. This picture is quite a good picture in that it shows you the default format for the 4 displays in the flight deck. So when you initially get onto the aircraft and you power that aircraft up, once the display electronics units complete their bite checks and everything's serviceable, obviously, then the format you will see is what's shown on this picture. So the format's pretty straightforward. You've got an auxiliary window and you've got a primary flight display with a what we call a mini map. It's just a small version of a nav display. On the captain's inboard display here, which is a multifunction display, and again, multifunction means we can show all kinds of information on there. It's not fixed to a particular graphic like the primary flight displays are. So on here we've got a nav display and an engine display. Okay. There we go. And oops, hold on a second. What's going on here? So we've got the nav display in what we call a narrow format, a compact format, and an engine display for the captain's side. Well, if we move over to the first officer side, then again we've got a multifunction display, widescreen, full format nav display there. And then for the first officer, we've got a primary flight display with the first officer's auxiliary window. Okay, so that's the standard basic layout once the aircraft's powered, the default format for those displays. Okay. This is a general description, and it's just showing the main components that go into the display system. The display system on the Max has completely changed if you compare it to an NG. You've got the display processor computers, there's 2 of those. They're in exactly the same location as they are on the NG, but they are not interchangeable, okay, and you cannot put a DPC into an NG, and you can't put a display electronics unit from an NG into a Max. They just won't fit. There's different locating pins on the back, and the DPCs are bigger than the DEUs. But the DPCs themselves are central to everything. Okay. Now, if you want to display anything, any kind of information on any of the 4 displays in the flight deck, it has to go through one of the DPCs. Okay, most information, most inputs that we get from other aircraft systems go to both display processor computers. Okay, the two DPCs themselves, they have a communication link between the two. Okay, an interbus connection link between the two, so they both know what each other's doing and the serviceability, the health status of a DPC. So we've got all kinds of information coming in here, as you can see, from all the aircraft systems. It's going to be shared with the DPC. Sometimes the information that comes to a display processor computer is only going to a DPC because the DPC is actually an interface and it can change analog to digital information, and it just goes straight through and out. Okay, it has no input at all to any of the displays. It's just using the DPC as an interface. So the inputs and the outputs to different aircraft systems or from different aircraft systems. We've got the 4 display units themselves. They're all the same. Okay, regardless of the position they're in. They're all the same. It's the actual physical position of a display that determines what it does. Okay, each of the displays have programming pins. Gives it an IP address, so it knows the position it's in. The display processor computers knows the position of those displays, so it knows what images to put on those displays. Okay. The output here, this signifies fiber optic, and towards the end of this lesson, I've got a video to play you about fiber optics, primarily to do with cleanliness of the fiber optic cables. So we've got fiber optic cables that are coming out the back of the display the display processor computers and going into the back of each of the display units. It's a standard fiber optic cable. It's a glass fiber optic cable on the Max, very similar to what they fit on the 87. Different to the 777X. The 777X is using plastic. It uses a plastic fiber cable, but this is a glass core. Okay, they are quite robust. You know, they are glass. You have to be careful with them, but they're not like a wine glass. If you drop it, you won't shatter it. Okay, but you do need to take caution with them. And the biggest problem I've seen with fiber optic cables is when people start to disconnect them. Okay, now I know that when it comes to fiber optic cables and all aircraft electrical cables, my background is avionics. I've seen many people in the past. Everyone knows that you're supposed to cap and stow electrical cables. Okay, I've seen all kinds of methods for capping, and I use that term very loosely. Capping electrical cables, from masking tape to speed tape to crisp packets, potato chip packets with a tie back round them. I've seen all kinds of things done over the years. You may get away with that with an electrical cable. Not that I condone it in any way, but you may get away with that with an electrical cable or a loom. But with a fiber optic cable, you won't get away with it. Okay, you really do need to use the approved caps for these blanks for these fiber optic cables, for the plugs, and also for the component that it's being plugged into. Okay, fiber optics is brilliant. You get very few problems with the fiber optic cable until you start to disconnect it. Okay, once you disconnect it, you need to cap it, because if the slightest little bit of FOD, a little bit of dust on the end of that cable, which is thinner than a human hair, which I've not got many of these days, you're going to have a problem. Okay, and you're just going to cause yourself more work. So if you know you're going to have to work in a certain area where these fiber optic cables, these fiber optic plugs, do your best to try not to have to disconnect those plugs, because once you disconnect them, you're opening to the environment, and the smallest bit of dust in the atmosphere can cause problems with fiber optic cables. As the old saying goes, if it ain't broke, don't try and fix it. Okay. All the fiber optic cables on the aircraft, and there's not a huge amount on the Max, to be fair, they are all purple in colour. So again, a standard single core fiber optic cable. We don't have multi-core fiber optics on these aircraft. They're just single core fiber optics. So we've got a cable going to each of we've got 2 cables in actual fact going to each of our displays, a cable from each of the display processor computers. Okay, going to the display units, we also have remote light sensors, one for the captain's side, one for the first officer's side. They're identical. They're not the same that are fitted to the NG. They have the ones on the Max have a wider or a slightly different area of detection, so they're not interchangeable with the NG, but they do the same thing. They're there to monitor the ambient light in the flight deck, and they're there to provide an automatic adjustment of the brightness on those displays. I'm trying to work my camera. It's a bit back to front for me. It's mirror. So I'm trying to move around so you can see me. So the light sensors themselves, I say, they're different to the ones fitted on the NG. They're over the glare shield. So you look over the glare shield, you'll see them pointing at you. You'll see the input from the remote light sensor goes to the display units. It's a little bit misleading. The remote light sensor goes to the on-side outboard display unit. It connects to it. The remote light sensor is receiving power, what we call a reference power, that it uses to power the sensor itself. And then as the light changes within the flight deck, it changes the output of that remote light sensor. And that output is going to the on-side outboard display unit. Okay. The on-side outboard display unit doesn't do anything with that information other than change it from analog to digital. Okay. From that point, digital information comes out of the display unit and goes to the display processing computer. Okay. The display processing computer will then change the brightness of the displays, and it changes the brightness in pairs. Okay. So the captain's and first officer's displays are split into pairs, 2 for the captain, 2 for the first officer, and they both change the brightness at the same time on side. So the display unit is used as an interface, very little computing power inside a display unit. We also have an input from the lighting control modules, and each of the crew, captain and first officer, have their own individual lighting control modules. We'll look at those again a little bit later on. But this allows me to change the brightness and the contrast of those displays, on-side displays. Again, this is analog information coming to the DUs. Okay. When it gets to the display unit, again, the DU will change that analog information to digital, sends it to the display processor computer, which then changes the brightness of those displays. Okay. We have brightness and contrast control for both displays because we can display weather radar, EGPWS information, terrain information on both inboard and outboard displays. Okay, normally it's only shown on the inboard display, but it can be shown on the outboard displays as well. So we have to have the contrast there so we can change the raster element of the color. Okay. The main panel brightness switch, that controls the actual brightness of the instrument panel itself. It has nothing to do with the displays. Okay, it's purely for the instrument panel. And then the PFD MFD switch, manual reversion switch. Okay, I'm not going to talk about it in a moment. I'm going to talk about it a little bit later on because I've got a better picture of this coming up. Okay, but that is what we call a manual reversion switch. Allows me to manually manipulate the panels, switch the displays. We also have an output going to the EFIS control panel. Okay, this output to the EFIS control panel is to do with this PFD MFD switch. This information comes through the EFIS control panel where it's digitized and then goes to the display processing computer. Okay, it doesn't go through the display units. It goes through the on-side EFIS control panel. EFIS control panel, well, again, I'll talk about that in a little bit later on. We've got a better picture of it. It looks very similar to the ones that are fitted to the NG, but it's not the same. Okay, it's not the same. So we've got the EFIS control panel again, allowing us to change the images that we show on primarily on our multifunction display normally. The instrument switching module, this is on the P5 panel. It's above the captain's head, same place as it is on the NG. It does exactly the same thing that it does on the NG. You've got a source selector, normally left in the auto position, and the system will then automatically switch the display processing computer for failures, for complete failure of a DPC. And we've got a control panel switch, again left in a normal position usually, but allows us to manually switch both on 1 or both on 2 for the EFIS control panels. Okay, and again I'll show you a better picture of that a little bit later on today. A new panel. This is on the P61. So at the back of the aircraft, as you come through the flight deck door on the right-hand side, you've got your data load panel like you have on the NG. Alongside that, above it, you've got this maintenance byte panel. Okay, and as the name suggests, it's to do with maintenance. Okay, flight crew would not normally have anything to do with this. It's primarily to do with maintenance, and we've got plenty of pictures of this coming up again as we go through the lesson, so I will talk in more detail about it as we get to it. But we've got a cursor control device. Okay, we've got a cursor control device here, allowing me to control the cursor on the display units. Okay, from the flight deck door, saves me having to reach in if the cockpit's got a few people in there. We've got a ground test switch. Again, the ground test switch is going to be used for ground tests at specific points within a ground test. It will tell you to put the ground test switch to enable to allow you to do that ground test. We've got a connection point here. This is to allow me to connect via a LAN cable, a fixed LAN cable, a hardwired cable. It allows me to connect a portable maintenance device, a computer of some kind. Okay, and then this one next to it, this is an actual physical plug, like a Canon plug or Hellman Deutsch plug. I'm not exactly sure which make it is, but it's a typical electrical plug. That allows me to put in, or should I say plug in, an external data loader. It is an option. Not all airlines have taken that. Okay. One panel that I didn't talk about, it's up at the top here, is the multifunction panel. This is the one that goes between the two flight management computer CDUs, where the lower display was on the NG. As its name suggests, it does a whole bunch of things. It's not purely for the display system. We've got things to do with fuel flow, the braking system. We've also got brake temperatures and such, like brake pressure, I beg your pardon, that type of thing. This is what we're interested in here for myself and us guys at the moment, is the MFD panel, the multifunction display panel, and the two cursor controls, these selectors here, one for the captain, one for the first officer. Okay, and again we've got a better picture coming up a little bit later on where it's zoomed in and we can see it in much more detail, and I'll go through it then. Okay, what functionality that gives us and how we use it. Okay. Component locations, well, again, you know, it's pretty straightforward. There's no significant changes to the locations of these components, really. The P5 panel with your instrument switching module up there for the source selector, again, on the overhead P5 panel. The glare shield, you've got your EFIS control panels for the captain and first officer. Just over the top of the glare shield, you'll have your remote light sensors, one for the left, one for the right-hand side. Down on the main instrument panels, you've got your 4 displays, outboard, inboard displays, PFD, MFD, MFD, PFD. And then down the bottom here, you've got your multifunction panel. Okay, the integrated standby flight display has absolutely nothing to do with the MAX display system. It is a standalone instrument. Okay, it still has pneumatic lines going in the back of it. It's not like the 87 that's completely electronic. But it looks similar to the one fitted to 87 and 777 and 47. Okay, so that's where our displays are located, and then down here we've got the control panels for the lighting control panels. Okay, so as I mentioned earlier, P61 panel, the maintenance bike panel. As you come through the flight deck door, up on the right-hand side, you've got your data load panel here. Just below it, you've got your maintenance bike panel. On the maintenance bike panel, you've got your maintenance selector switch. This has a left and a right position for this outermost rotary switch here. It's a 2-position switch, either left or right. That determines where the cursor is going to go. It's going to go either on the left inboard display or the right inboard display. And when you move that switch to left or right, nothing happens on those displays, okay, until you move that rotary control there. This is like 3 controls in one. You've got the outer selector, you've got the rotary control here. I believe on 777, I was always told when I was teaching 87, they call it a tabber, okay? Very much like a tab key on a computer. Every click of that rotary control moves the cursor to the next available position. Okay, so you've got this rotary control here that allows you to move the cursor around that screen. Once you move that rotary control, the cursor shape will then change. Okay, the actual shape of the cursor that we use is different depending on whether the captain, first officer, or the maintenance bike panel is controlling the cursor. For the maintenance bike panel, it's like 2 wrenches, 2 spanners that are crossed, like so, okay? Because obviously maintenance, they only have wrenches in their toolboxes, nothing else, so I guess that's global. As an avionics guy, I also had spanners, wrenches in my toolbox, but anything bigger than a 1/4 inch, it was always classed as B1. So so we use spanners because I guess it's known throughout the world. So as maintenance, so you've got the cross spanners, the cross wrenches, okay, and then you can move that cursor from the door area. You don't have to clamber through into the front of the flight deck to get access to the multifunction panel. The select switch, that's what I'm going to use to make a selection. So once I've got the cursor to the area that I want, it's just like a mouse button. Press the select switch and it will select whatever I've got the cursor on. Okay. The ground test switch, it's a guarded switch. It's guarded into the normal position. So when the cover's down, the guard's down, the switch is forced into the normal position. Many ground tests will require you to move that switch to the enable position. Okay. Lift the guard, move the switch, move it to enable, and it stays in the enable position. It's out of sight. Okay. It's out of view of the crew. So when you're sat in the flight deck and you're sat in the captain's or first officer's chairs, it's right behind you. Even the observer's seats, it's pretty much behind you. So it's out of view. This switch is tied to a status message. Okay, whenever the switch is not in the normal position, you will get a status message, a ground test switch status message on your status display, which we'll look at later on. Whenever you have an active status message, okay, that hasn't been deferred, or a fault that has a status message that hasn't been fixed, then you will have the maintenance light on. The maintenance light is on the P5 panel. It's where the PSEU fail light was on the NG. That maintenance light will always show when the aircraft's on the ground, okay, if you have an active status message. Because that switch is in the enable position, you have an active status message. It's reporting to the maintenance function, okay, the onboard maintenance function. So it will give you a status message, and because you have a status message, you have the maintenance light. When the crew take the aircraft, when maintenance release it, one of the checks the crew have to do is to make sure that that light is not on, that maintenance light is out. If you've left that switch in the enable position, the maintenance light will be on, okay? So you'll have to come back, put the switch to the off position or to the normal position. So just be aware of that. If you do follow the AMM, and you should be following the AMM at all times, it will tell you to put the switch back to the normal position. Okay, and if you're following the ground tests on the max display system, it will also give you warnings and tell you preconditions for that switch. Okay. Down here, you've got the LAN connector, and to take that plastic cover off, it's just a plastic dust cover. I've seen a mix and match. I've seen all different colours, blacks, reds, yellows, whites. I've even seen some proper fixed metallic covers like the one you've got here. But behind there, you've just got a standard LAN connector, a standard socket allowing me to connect, hardwire a portable maintenance device to the aircraft. The one next to it is for remote data loading. Again, if you've got a remote data transfer unit, it's an electrical connector. Again, it allows you to connect that portable maintenance device. Okay, but that is an option. If you don't have the option, then you just have a blank over there. Okay, there's no plug fitted. So that's the excuse me, the maintenance bike panel on the P61 at the back of the aircraft. This is showing you the location of the glare shields. Okay, the glare shield itself, over the top of the glare shield, you'll see the remote light sensors there to monitor, as I've mentioned, the ambient light in the flight deck. Okay, and automatically they will change the brightness of those displays for you. They're not the same that are fitted to the NG. I've already mentioned that. Down in the electrical equipment bay, these are 2 display processor computers. So we've gone through the hatch underneath the aircraft. We've turned about. We're looking aft. Directly up there on the E31 rack, you've got the display processor computer number 1, which is on the right-hand side, as you can see here, looking aft. and DPC number 2. They're both the same, both identical. Both should have the same software loaded inside them. They are pin strapped for location. There is crosstalk between the two DPCs. Okay, don't forget that these DPCs have fiber optic connections. Okay, so if you do pull a DPC out, make sure you put a cover, a dust cover over those edge connectors. Okay, if you don't, you're going to cause yourself problems, especially when the aircraft's been in service for some time. Some of the aircraft I've been on over the years, I mean, the dust is in there is worse than what's under my daughter's bed. Okay, so you know you've got to be careful with fiber optics. So always put a cover on the connector itself and put a blank on the DPC. Okay, especially if you're going to be reinstalling it at a later date. We will look at power supplies for the DPCs in a moment, but it's worth noting that whenever the aircraft battery, which is down here, whenever the aircraft battery is plugged in, it doesn't have to be switched on. Whenever it is plugged in, the hot battery buzz is live. Okay, whenever that battery is plugged in and that hot battery buzz is live, those DPCs are receiving voltage. They are receiving a power supply. So if you get the, if you're in a position where you are being asked, or you are asking somebody to change a DPC, if you're going to rob one off another aircraft to dispatch the aircraft, let's say, and you go onto the aircraft and there's no power on it, the battery's off, the external power is disconnected, but the battery's still plugged in, you need to follow the AMN procedures for removal of a DPC. Okay, don't just pull it, because there are power supplies still going into that DPC at the back. Okay, so just be aware of that. They are air-cooled via the normal condition in the E&E compartment cooling system. They have a forced air supply. They also have an exhaust supply. On the MAX, Brian will go through tomorrow, but on the MAX aircraft we have optical smoke detectors in both the supply and exhaust lines for the electrical equipment bay. Okay, optical smoke detectors, really smart ones actually, very neat. This is showing you the power supplies themselves. I have just mentioned them to you. Captain's controls and equipment on here, and first officers on the other side. You have to forgive me with this. I don't know if you can see this thing keeps dropping down over my display. I'm still getting used to WebEx. I've not done many WebEx sessions over my history. I'm normally still up in class doing a talk and chalk. So this is just showing you the power supplies for the MAX display system components. You've got the display units, inboard and outboard display units for the captains and first officers. You can see the captain side is off the standby bus, so it's a higher level of redundancy for the captain. The captain's displays will still be available on the standby bus. You'll also see on the other side here for the first officer, again, all the power supplies for the first officer's controls and instruments are coming from the DC bus 2. Okay. Maintenance bike panel. So the maintenance bike panel P61, again, DC bus 2. The multifunction panel is coming from the standby bus. Again, it's important, more important than the maintenance panel at the back. Okay. And then the DPCs. So again, captains and first officers DPCs have two power supplies. A normal power supply, either from the standby bus for the captain or 28 volt DC bus for the first officer. Oh, for DPC number 2, first officer side. DPCs normally feed displays, on-side displays. Okay, so the number 1 will do the captains, number 2 will do the first officers. But they can mix, they can switch, and I'll show you that in a moment. You'll also see we've got two power supplies down here. These are what I was just mentioned to you. They're the power supplies from the aircraft's hot battery bus, the main aircraft's hot battery bus. 28 volt DC directly from the battery. The DPCs use that for a number of reasons. It says hold up power. So the display processor computers, when you initially power the aircraft, they go through like a byte test, a power up byte test, a built-in test. It takes around about 25-30 seconds for those display processor computers to fully complete that byte. What's happening with this hold up power is that, let's say we've got the aircraft powered from external power, a Stinger's plugged in, and we switch power sources. We switch onto the APU generator. We will have what we call a power break transfer. okay, where the electrical system is reconfiguring itself to allow the APU generator to take control. It's a few milliseconds, but it's enough to break the power, okay, the power supply to these components. That's the last thing we would want to do, is to interrupt the power supply to a display electronics unit, sorry, display processor computer. The display processor computer could reboot itself, and then you have to wait again for it to do its power up byte. So the hold-up power is there to maintain a constant power supply to those display processor computers when we switch power sources, okay? What we call a hold-up power. It's also used for when we power the aircraft down. These are computers at the end of the day, okay? They have volatile and non-volatile memory inside them. Anything in volatile memory, you pull the plug, you've lost it, okay? So if things are moved from one memory to another as we start to shut these components down. So as I get to the aircraft and I switch power off and I switch the battery off, then the systems will go through a shutdown, okay? It takes around about 10 seconds for them to shut themselves down, but they go through what we call a staged shutdown, okay? You wouldn't get your laptop and shut it down by pulling the battery out of it. You're going to lose anything that you've done, any work that you've done on that laptop. We use a similar sort of approach to when we shut down these computers. We shut them down in a structured manner. Once the aircraft is depowered and they've gone through their normal shutdown, everything's okay. They're actually shut down at that point. The power supply is still maintained though. We've still got that hot battery bus supply to them because inside the DPCs we have the clock and calendar function, okay? So inside each of those display processor computers is a function that we use to allow us to display the current time, UTC time and date in the flight deck on the auxiliary window. It's also used for other things, time and date. It's also used for many other things other than just displaying it. But that display is receiving the time and date from the DPCs. The DPCs are getting that time and date from the global positioning system, the GPS system. So when the aircraft's outside and it's receiving GPS, the clocks are updated automatically. If it's in the hangar, it's shielded from the GPS satellites, then we're reliant upon the battery to keep that clock function up to date, okay? So we need that power supply for the clocks. So it's used for a whole bunch of things, for hold-up power, for when we have power interrupts, changing from one power source to another. We use it to shut the DPCs down correctly, okay? And we also use it to maintain power to our clock and calendar function. So just be aware that when you do, if you do get involved with pulling out a DPC, that you need to start to pull circuit breakers because they are still powered, okay? Is everyone doing okay? It's like I say, it's very different not being in the classroom with everyone, but I hope it's coming over okay to you. Okay. So this is looking inside the display processor computers, okay? As I said to you before, they're both the same part number, okay? Just in different positions. The position of the computer itself determines the actual position of the computer determines whether it's the left or right. But internally, they're both the same, and they should have the same software within them as well. So inside the DPC, if we look at display processor computer number 1, this one here, then inside it we've got some graphics cards, okay? 2 graphics cards inside those display processor computers, okay? On each of the graphics cards we have a graphics generator, 2 graphics generators on each graphics card. So each DPC has 4 graphics generators. That enables the DPC to display 4 independent images, okay? So the DPCs are more than capable of displaying an independent image on all 4 displays in the flight deck, if they had to. However, the way we configure these is that the DPC number 1 will normally supply an image, a graphic, to the captain's displays, and the DPC number 2 would normally supply displays or graphics to the first officer's inboard and outboard displays. Those displays receive that information via those fiber optic cables, and as I said to you earlier, each display unit has two cables, two fiber optic cables, as well as a physical electrical plug, okay, a separate plug for electrical power and such. So these two inputs here, the blue one is coming from the DPC number 1 and the red is coming from DPC number 2. In actual fact, all fiber optic cables are purple in colour. Well, this is just to give you an idea on a picture. So the inputs are coming into the display units. Graphics generators, we don't use them all at the same time. Without going into huge amounts of detail, because this is just a refresher, graphics card A, graphics generator B would normally feed the outboard display unit for the captain. Graphics generator B would normally feed the inboard display unit for the captain. Okay. These ones are not normally used. Okay, only used if we lose a graphics generator within the same DPC or within the opposite DPC. All the switching, okay, is done inside the DPCs. It's not the same as the NG. On the NG, you had the coaxial connectors coming from the display electronics units to the displays, and you had a switching unit, a coaxial switching unit that did the switching. On this aircraft, all the switching is done by this fiber fabric card. Okay. I'm just going to try and mute everyone. We've got some background noise there. Hopefully that will cure that for us. So the fiber fabric card will do that switching for us automatically. Okay, or it should do it automatically. What we don't show on here is a connection between the two display processor computers. They do have a crosstalk bus, so they are aware of each other's health, status. Okay. When we look at DPC number 2, again, normally it would just feed the display units for the first officer. Okay. Slightly different, the arrangement they do it. In this case, it's graphics card B. Graphics card B, graphics generator A would feed the right inboard display unit for the first officer, and graphics card B, graphics generator B, would feed the first officer's outboard display. Okay, so it is just slightly different in the configuration, but it doesn't matter. If you swap the two units over, you don't have to do any changes. It's done automatic. They know the position that they're in because of the pin strapping on the connectors, the back connectors. So this is all fiber optic. Okay, there's no other component between the DPCs and the display units other than plug breaks. Okay, so it really is just the fiber optic cables and those plug breaks between the two. As I said to you earlier, if you do get involved with changing any of these components out or dismantling, disconnecting a plug break, please make sure you put the correct covers on, the dust covers on. If you don't, you're just going to cause yourselves more problems, okay, more work. All right. Cleaning a fiber optic cable on the aircraft is not too hard. Most people, most airlines, certainly with the 87, and I would imagine that the airlines who are going to have MAX as well as 87s, or airlines who are just having the MAX, they will use the same processes, and they will use these pens, these cleaning pens, okay, rather than the wet and dry swabs. The video at the end I'll show you, it shows you the cleaning pens. They're a one-shot thing. You just keep punching it like so, and it just clicks and it cleans and then dries the fiber optic cable. Okay, not so bad to do on the aircraft. If you damage a fiber optic cable, well, you can repair them. We do have an approved method for repairing fiber optic cables now, but it's more painful than pulling your own teeth out without any kind of injection. It really is. It's a complete and utter nightmare to repair a fiber optic cable. In my honest opinion, it would be far simpler just to replace it. Okay, it's very difficult to repair a fiber optic cable when it's on the bench, let alone when you're routing inside an equipment bay full of dust, banging your head, leaning on rivets, and people trying to squeeze past you. Okay, so again, be very careful with fiber optic cables. They can be repaired, but it's not straightforward. It really isn't. For those of you who have a My Boeing Fleet account, I imagine most of you will, if not all of you, you should have you will have a training tab that's of some kind in your My Boeing Fleet account, like a toolbox account type of thing. On there you'll have a training tab. It's worth having a look at the training video for repair of a fiber optic cable. Okay, the actual video is about 40 minutes long. showing you how to repair a fibre optic cable, the equipment you need to do it. You could buy yourself a beautiful family home with the equipment that you need to buy to repair a fibre optic cable, okay? So again, just keep that in mind, bear that in mind. There's not a lot of fibre optics on the Macs. It's all purple. If you come across it, be careful with it. These outputs here, these outputs are coming from the DPCs themselves. It is a digital connection, okay? This is just a loop. It's a feedback loop, okay, from the display units to both display processor computers. So if I lose a display processor computer, I don't lose the brightness and dimming controls from the remote light sensor, okay? It's shared, so I still have that dimming capability, okay? These outputs here, as I say, are an ARINC digital output, ARINC 429 I think they are, if I'll have to check, but I'm pretty sure it's a 429 output. But you see it says DPC1, DPC2, so this information is going to both display processing computers. Information relating to brightness, relating to the health of the display unit, also information relating to the position of a display unit, and whether the information that you're supposed to be displaying is actually being displayed. So if I lose a display unit, let's say a circuit breaker trips for whatever reason, and I lose power to a display unit, the display processor computer will see that. It knows it's lost a display, so it should automatically reconfigure those displays depending on which display has failed, okay? If it doesn't, you've got the manual reversion switches that I mentioned earlier, okay, that you can manually turn. We'll look at those a little bit later on. Okay. At this point, I would normally show the video, but I'm not going to show the video at the minute. I'm going to show it at the end once we've completed all of this. I'll probably go for another 25 minutes and give everyone a break. 25 minutes and give everyone a 10 or 15 break, if that's okay with everyone. The problem with not being in the classroom is I can't see when people go into what I call the shark mode. It depends on what time of day it is and whether you've eaten lunch or not, but people drop into a shark mode pretty quick after lunch, or especially if I'm talking for too much. Shark mode is when the eyes glaze over and the eyes start to roll back. At that point, I usually call time for a break. But we're not being able to see many people. I can't see how many people's eyes have rolled back and dropped into a shark mode. So I'll just have to try and time it right, okay? This is just showing you the brightness interfaces. I have talked about it, I've mentioned it before. The DPCs themselves, okay, the inputs, these are digital inputs, okay, they're not fiber optics, they are digital inputs coming from these, to the DPCs, I beg your pardon, coming from these display units, okay. So these outputs here are these inputs to the display units. These are the outboard display units, captains and first officers. Inboard display units for captain and first officer. BLS, bezel light sensor. A bezel light sensor is a sensor, electric cell, photoelectric cell that's actually part of the display unit itself, okay? Each display unit has its own independent light sensor, and that bezel light sensor will control the brightness automatically of that display, the display it's associated with. If, let's say, I'm flying along in my aircraft and I roll the aircraft and the sun comes through one of the windows and completely washes out a display, a PFD, let's say, then that bezel light sensor will see that. It sees that brightness hitting the display. And what it will do, it will increase the brightness to that display to try to maintain visibility of that display to the crew. It doesn't do it directly, it does it via the DPC. So again, there's no direct control for brightness of these displays. It's all done via the DPCs, okay? These are the lighting control modules, captains and first officers, outboard display and inboard displays. As I say, you've got a contrast and brightness for both on-side displays for controlling the brightness, but also for the contrast. So I can change the brightness, or the contrast levels, I should say, for the weather radar information and the terrain information, okay? As you can see, that information goes to the displays themselves. This is this voltage here, again, coming out to the different rotary controls is a reference voltage coming from the actual display unit itself. The remote light sensors, we've already mentioned those, the left and right remote light sensors that are over the glare shield. They receive a voltage, 15 volts DC, from the outboard on-side display unit. And that voltage is used not only to power the remote light sensor, but also used as a reference voltage. And then as that light inside the flight deck increases or decreases, it changes the output voltage back to the outboard display unit. The outboard display unit will then change that analog input to a digital output to the DPC, which will then change the brightness of the two on-side displays at the same time. Okay, so the remote light sensor controls the brightness of two displays at the same time. You'll also see that this is the digital flight control system, mode control panel for the autopilot flight director. It also receives power supplies from both the outboard display units, okay? And that's purely for its lighting circuits inside, okay? Purely for the lighting system. So that's your very simple schematic. I like simple schematics, much better than difficult ones. This one here is just to give you an idea of everything that goes to a DPC, okay? Lots of on the line and base courses, differences courses, people panic, I guess, when they see this because they think there's going to be exam questions on it and they're like, oh no, I've got to remember all this, okay? It really is just to give you an idea. And I should have mentioned as well at the beginning, I beg your pardon, obviously there's no exam for this, so you can just relax, you can and just take it in. You don't have to worry about what's coming up on Thursday at the end of the day. There's no exam. So this is just showing you the inputs to these DPCs. And I've mentioned to you before, if you want to display anything on any of those four displays in the flight deck, it has to go through a DPC. Nothing goes directly to be displayed on a display. It has to go through a DPC. Most things, as you can see here, that are coming to the DPCs go to both. So DPC number 1, DPC number 2 receive digital information, analog and discrete information as well, okay? They may use that information for displays. It may be used just to digitize it and send it on, okay? But it goes through the DPCs, and normally it goes through both. These are some of the systems that go that actually have a connection to the DPCs, and then these are the outputs again, digital outputs, ARINC outputs. So anything you see like a very thick arrow like this that's hollow, that's white in color in the center, is an ARINC. Probably more often than not 429, maybe some slightly different ones as well. These are discrete or analog inputs or outputs, okay, as you can see here. And these ones are Ethernet connections, okay, so Ethernet cables that are plugging into the back of these DPCs as well, okay. So for the flight management computer, the network file server, okay, and we'll look at those a little bit later on too. There's always exceptions in everything in life, and the DPCs are no different. The hydraulic system, the pressure, this is the same on the NG, okay, for the DEUs. The hydraulic systems, the pressure, system A and system B is sided. This information is not shared with the display processing computer, okay. So system A for hydraulics goes to DPC number 1, system B goes to DPC number 2. It's only for display, okay, of pressure. It has nothing to do with the hydraulics panel, nothing to do with the fault light, the low pressure lights or anything of that nature, okay. If I lose a display processing computer, the only thing I will lose when it comes to hydraulics, so long as the hydraulic system is serviceable, is the indication of pressure on my systems page, okay. That's all I will lose, nothing else. So that is the exception. Okay. And the remote light sensor. Someone spent a lot of time making that graphic. It looks nice. It is a remote light sensor. What can I possibly tell you about it other than it's not the same as the one that's fitted to the NG, but it does exactly the same thing as it does on the NG. It does what it says on the tin. It's a remote light sensor. Sensing the ambient light in the flight deck. Okay. Changes the displays automatically to maintain that set brightness. The actual field of view here is slightly different to the NG. It's a different field of view, so it's not the same. But one either side, they stick up, they protrude just over the top of the glare shield you'll see those two light sensors. Okay, they get their power, as I've said, from the on-side outboard display unit. Oops. There we go. And there's the display units. Okay, nothing to them. I don't know if anybody's ever got a hold of one of these, removed one, carried one around. There's no weight in them at all. Okay, you certainly don't have to be Arnold Schwarzenegger to get these out. Some of the old stuff that I used to take out, you used to have to move the control columns right back, get your knee behind the control column if your mate wasn't with you, grab the cathode display and try to pull it out without smashing the display on the front. These are very light. They're a liquid crystal display. They're all the same. There's not much to them because they are pretty much just a display unit, a little bit of computing power in there, but not a lot. Most of the weight is to do with heat sinks to dissipate the heat that's generated by the displays. I'm sure all of you, well, most of you, if not all of you, have seen them at some point. If you haven't, then they are a really good display. They give you a crystal clear image, very little glare on these displays. Bone have used them for many years. As I say, they're currently fitted to the 8.7. To get them out, quite simple. The displays, all four are the same, so it doesn't matter which position you put them in. Okay, they know the position because of pin strapping. Okay, they know where they are. So a display, to remove it, you've got the grab handles here. They are normally folded down on themselves, covering these two screws. Each of these handles has two screws themselves. Okay, they are supposed to be, and they certainly are when they leave the factory, captive screws. But I'll never take anything for granted, especially when it's been in service for a while. Okay, so whenever somebody tells me it's captive, I think, well, okay, it's supposed to be. So when you undo those screws, just be aware of that they may no longer be captive, depending on how many people have taken them in and out in the past. But undo the screws and the handles fold in. I'm trying to get my hands right. There we go. The handles fold inboard like so, hinged. Okay. As you move those handles in, they reveal these two screws. These two screws, again, are captive, or supposed to be captive. They physically hold the display unit into the instrument panel. Once you've done those four screws, you just grab hold of the handles and you pull the panel out. There's no fixed edge connector, okay? It doesn't slot into an edge connector or anything like that. They are a physical loom, okay, that follows the panel out. Disconnect the looms. One's fiber optic, this one here. One's electrical, okay? Make sure you cap them both the electrical and the fiber optic cables, the looms, and the display units. Okay. The display units themselves, they are cooled. The captains have what we call a forced air supply cooling, where we physically force air into that display or into those display units. And we also have an exhaust system that sucks the air, draws the air out of those display units. So we've got a constant flow of air going in and going out of those two displays. The air going into, the air coming out of those displays goes over a smoke detector. It's part of the equipment bay cooling system. Okay. First office is slightly different. They just have exhaust cooling. So we're just sucking the air out of the displays. If you look at the displays, you've got some cooling holes, some ventilation holes. Looms, harnesses, I beg your pardon. I guess it's whatever part of the world you come from. Harnesses, looms, same thing in my book. Okay. Someone's asked me a question there. We've got cooling holes around those displays. For the first office, as I say, we've only got exhaust cooling, so we're sucking the air. As we suck the air through the displays, it's sucking the air from the instrument panel or from the back of the instrument panel. So we've got a constant movement of air there. It allows us to move the air through the display units, but also move the air from the back of the instrument panel as well, okay, to make sure that nothing becomes stagnant. And again, that air that we're taking out as exhaust, we are using that and sending that across a smoke detector, okay. So they're the panels. I think we've got a little video, which I'm going to show you now. There's no sound to it. It's a very quick video that shows you how to replace, he says, there it is, how to remove one of these panels, just in case you didn't believe me, okay? So I shall, he says, oh, don't you just love it when a plan comes together? Come on. It's decided not to show it. Okay, don't panic. There we go. I'm hoping you can see this. Okay, maybe not. Hang on a second. Let me try again. I don't know how it's doing this. Hang on. Let me close that. I'm just going to stop sharing for a moment. This is an issue with WebEx. Let me just bring this up, like so. Okay, there we go. I will be 2 seconds, and I will share my display with you again. There we go. Hopefully you can see it now, and I will press play. There's no sound to it, but it's just showing you basically what I've just told you. Okay, so the displays, there's the handles, the little captive screws that you undo, fold the handles in, 4 screws that hold the display into the instrument panel, and then just grab the handles and pull them out. They're very light. There's no weight to them at all. I think they just weigh about 5 kilos. So there's very little weight to them. There's the fiber optic cables, the 2 fiber optic cables there, and the electrical plug. Like I say, please make sure you cover both of those looms, those harnesses, and also the actual display itself, the sockets. The last thing you want is to cause yourself more work. Nobody wants to do that. Okay. What I will do is I'll call a break, if that's okay with everyone. As I say, I'm not sure. We've got people from all over the world ringing in today, so it's going to be evening for some, afternoon for others, and morning for others. So I'm not going to give you the hour because it's going to be different wherever you are. So judging by my watch, it's just gone 20 past the hour. So let's say 25 to the hour. Is that okay with everyone? 25 to the hour will start again. Okay. Thanks very much, guys. I shall speak to you in a moment.